The previous AIPMT question from the laws of motion. The problem is like this. A bullet is fired from the gun. The force on the bullet is given by, that means the force on the bullet is varying with respect to time. As per the given problem, force is 600 minus 2 into 10 power 5 of t, where F is in Newton and t is in seconds, obviously, right? The force on the become bullet zero as soon as it leaves the barrel, right? What's the average impulse is, right? So first I need to calculate when the force becomes zero, after how much of the time. Let after time t force becomes zero. That implies equate this force to zero. 600 minus 2 into 10 power 5 times of t, like what he has given. Then 600 by 2 into 10 power 5 is the time after which the velocity and the force on the bullet becomes zero, right? Okay, that is 600 by 2 into 10 power minus 5. Then that is 300 into 10 power minus 5. That is 3 into 10 power minus 3 seconds. So after a time of 3 into 10 power minus 3 seconds, its force is going to become 0. Let us take that point into consideration and proceed further to solve the problem. We know we need to calculate impulse. Impulse or average impulse is defined as force acting on a body for a small interval of the time. As you have considered small interval of the time, the impulse that you get also will be small. So di will be f into dt. I know already the value of f given in the problem. 600 minus 2 into 10 power 5 times of t dt. This is a small change in impulse in the small interval of the time. I want the total impulse. To get the total impulse, I shall calculate the impulse for each of the delta t's and add all of them. Doing that like that mathematically is called integration. So we shall integrate this equation. Integral of di is integral of 600 minus 2 into 10 power 5t dt, where the time is varying from 0 to this value because it started at the 0 time and it's ending at 3 into 10 power minus 3 seconds. These are called upper and lower limits of integration. That implies differentiation of integration of I is impulse. So impulse is equal to 600 dt from 0 to 3 into 10 power minus 3 minus integral of 2 into 10 power 5 t dt. Also the same time intervals. I have just applied upper and lower limits. 600 integral of differentiation of time is time, whose limits are from 0 to 3 into 10 power minus 3 minus 2 into 10 power 5 is constant. There's the formula as you know, integral of x power n dx equal to x power n plus 1 by n plus 1. Now t power only 1 is there, so integral of t power 1 dt is t power 1 plus 1 by 1 plus 1, that is t square by 2. So this term integration becomes t square by 2, whose limits are from 0 to 3 into 10 power minus 3. Let us simplify this. 600. First I shall apply the upper limit in the function and then minus lower limit. In the place of t, upper limit is 3 into 10 power minus 3, minus lower limit is 0, minus 2 into 10 power 5. By 2 I can take it outside. T square. Upper limit I have to apply 3 into 10 power minus 3 whole square minus 0 square. That's the lower limit. So if you simplify this, 600 into 3, 1800 into 10 power minus 3. 2 and 2 will cancel. 10 power 5. 3 square is 9 into 10 power minus 6. So 1800 into 10 power minus 3 means 1.8. 10 power minus 6 into 10 power 5 means 10 power minus 1. 9 into 10 power minus 1 means 0.9. So that's value is 0.9. Units of impulse and change in momentum are same. So the answer is 0.9 kilogram meter per second or Newton per second, right? That's how we can calculate the problem, right? That's how we get the answer, right? So while you are solving this problem, we have followed a very simple concept. First, as he said, force becomes zero as and when it leaves. We have calculated after how much time that becomes zero. Then we have used the very definition of impulse, and we have applied integration so that I can get the entire impulse, and I have simplified so that I got the answer. And I used a very simple formula of integral of x power n dx equal to x power n plus 1 by n plus 1. This is a quite frequent formula. You use it so many times in plus 1 and plus 2 problems. That's it. Thank you for watching.